And welcome to the Kennedy Space Center, where we are preparing for our launch of the New Horizons to the planet Pluto. This is our pre-launch press conference for the launch that's expected to take place in 2 days. On our panel today is Dr. Colleen Hartman, the Deputy Associate Administrator for Science Mission Directorate at NASA headquarters in Washington. Omar Baez, who is the NASA Launch Director and Launch Manager at Kennedy Space Center. Mike Jensen, the Vice President and Chief Technical Officer of the International Launch Services. David Kuchnarkevich, New Horizons Mission Systems Engineer at the Johns Hopkins University Applied Physics Laboratory. And Joel Tumbiola, the U.S. Air Force Launch Weather Officer at the 45th Weather Squadron at the Cape Canaveral Air Force Station. We'll come back here and I'll go down and let each of these have an opportunity for opening comments, beginning with Dr. Hartman.
Thanks. I'd like to set the Pluto mission in context of other NASA goals, and today I'd like to convince you that now is the time for a great new American enterprise, time for an exploration vision which Administrator Griffin has laid out, and an adventure which will impact the minds of women and men everywhere on Earth who are attempting to determine which road they should take. America will go back to the moon and explore it with new robotic and human eyes, with a view toward mining the resources we require to go further on the journey. Then on to Mars, where today NASA robotic spacecraft continue to explore the surface and chart the terrain for future human exploration. Then beyond to the edge of our solar system and the tiny planet Pluto, opening up a new frontier. The United States, as an ambassador for the world, has visited every planet with a space probe, from the innermost rocky Mercury, where the temperature gets so hot it could melt a tin pan, to the outermost frigid temperatures of minus 360 degrees Fahrenheit at the gas giant Neptune. Our spacecraft, Pioneer, Voyager, Galileo, have provided marvelous close-ups of Jupiter, Saturn, Uranus, and Neptune. Yet no space probe has ever visited tiny Pluto, the first planet discovered by an American and the only planet discovered in the 20th century. NASA's New Horizons mission to Pluto is poised to excite, and it has a lot of other firsts. But even more exciting is that discoveries in the last year, indeed, in fact, in the last 6 months, have changed what we expect to find. It's the first visit to a planetary binary system with Pluto's tiny companion, Charon. Just last year, however, Hubble observations suggest that there are 2 additional moons orbiting Pluto. It's the first visit to the 9th planet. But before about 6 months ago, we thought that Pluto was the 9th and last planet in the solar system. That may not be true either. We have a potential discovery of a 10th planet that the discoverers have nicknamed Xena, and they saw it with the Palomar Observatory Reflecting Telescope in California. It also has a companion they call Gabriella. For fans of Xena Warrior Princess, I think you might agree with me that the astronomers have been watching too much TV. It's the first visit to an icy dwarf, a misfit in the solar system, or so we thought, given that we have rocky inner planets and outer gas giants. But it's not a lone oddity. In fact, it's the brightest of a vast collection of objects orbiting Neptune. Did Pluto and other members of the Kuiper Belt feed the young Earth with the raw materials for and organic compounds of life? It's the fastest spacecraft ever launched. It'll get to the moon in 9 hours, whereas it took the Apollo capsule a little more than 3 days. It'll get to Jupiter in 1 year and 1 month, whereas it took Cassini 4 years. This is a strange and fascinating world to visit. Pluto's home is the solar system's deep freezer. The Kuiper Belt, that ancient icy and chilly third zone of the solar system that begins 3 billion miles away from our sun, and it's filled with a swarm of maybe 100,000 miniature planets. Pluto itself is so far away from Earth that it's 50,000 times fainter than Mars. We can barely make out Pluto with the powerful Hubble Space Telescope and a 500-kilometer resolution. This strange body has a surface composition of nitrogen, carbon monoxide, methane, water ice, and maybe other materials yet to be discovered. Due to its orbital tilt of 17 degrees across the ecliptic and an orbit around the sun of 248 Earth years, its tenuous atmosphere and strange seasons are just awaiting our probe. The atmosphere is thought to bleed into space much like a comet's. The estimated surface temperature, minus 387 degrees Fahrenheit, A suggestion of expensive polar caps and organic compounds, such as frozen methane on the surface and water ice in the interior, make it an interesting place. Is there perhaps volcanic activity on Pluto, much as we found on Triton, a very similar moon that orbits Neptune? This probe will go to Pluto and approach at 14 kilometers a second. That's more than 31,000 miles an hour. Then as it flies past the planet, it'll turn and map the planet's night side using moonlight reflected from Charon. A powerful radial beam from Earth will then be directed to pass through Pluto's atmosphere, helping us probe the atmospheric temperature and density profiles. But in conclusion, what I want to ask with all of this is still, why is NASA going to Pluto? Yes, you'll hear this afternoon from other scientists about the specific and wonderful scientific investigations that we've planned. But why go? When I was a child, the textbook said that the solar system was well known. If you didn't happen to be lucky enough to have the mind of the brilliant mathematician Johannes Kepler, who determined the laws governing the heavenly bodies, you really weren't going to be the one to discover anything this new. There'd basically been no mountain left unclimbed. This turns out to be far from the case. What we know about Pluto today could fit on the back of a postage stamp, and I'm sure you'll hear and you believe that the textbooks will be rewritten after this mission is completed. But to me, that isn't all. I believe that one of the most compelling reasons why America is going to Pluto is to discover what we don't know. This is why we have a great American enterprise, a time for the nation to take a clearly leading role in space achievement, which may hold the future here on Earth. This is the true nature of exploration, to discover questions we don't even know yet how to ask. And then, only then, perhaps, some of the answers. Thanks.
Thank you, Dr. Hartman. And now we'll hear from Omar Baez, who is the NASA Launch Director. Omar.
Thank you, Bruce. I'm here to give you a status on the processing of the launch vehicle and into the launch countdown tomorrow and Tuesday. First, I got to give credit to the folks working really hard to get this mission off, and this started years ago, not just in the last couple of months. And folks working very hard to design the hardware, to design the mission, to achieve what it's going to achieve in the next coming 9 years. So a lot of thanks goes out there, and I'm going to be rolling a tape here on the hardware. Someone roll that tape, please. And this is the culmination of all that hard work, actually seeing the hardware here. This is the Antonov arriving with the Atlas first stage. That happened back in September. We actually put that booster up September 29th. There you see it rolling out to the pad. The booster was put up on the 29th, and the Centaur, which you'll see coming up briefly, followed it and is completed on October 16th. We'll also see the solid rocket motors. We have 5 of them on this vehicle, and the SRMs on this vehicle provide close to 400,000 pounds of thrust each. That first stage, when it lights up, is going to be producing close to 3 million pounds of thrust. There's the Centaur coming up on the tape here. And as soon as that's set down, we start our checkout of the first stage with the second stage Centaur. And once that is complete, we await the arrival of the spacecraft and the encapsulated within the fairing. Here's the SRMs coming back, and there's, you notice I've been talking about SRMs and first stage and second stage. We did this quite an awful lot due to Hurricane Wilma. We did take some damage, and we did have to take some of the, or one of the SRMs down and replace it. So it wasn't quite in the order we would have liked to have done this work, but we got it done. And here's a picture of it with the 5 SRMs in place. This is on December 15th when we did our wet dress rehearsal. We tanked the vehicle with the cryogenics for the first time. and this is December 17th, when we took the spacecraft encapsulated within that fairing there out to the launch pad for its mate to the Atlas and Centaur. After we completed this mate, we ran our integrated systems test, which is a electrical test of the vehicle, flying it through its flight profile, and obviously not lighting any of the motors or anything, but simulating the way we would normally fly this vehicle. We did 2 dress rehearsals on this mission to get the team ready, one on November 10th and one on December 15th. After the holidays were concluded, we came back hard at work and ran the vehicle through its paces, what we call our F-8 to F-2 day, which is where we're at now. And that is to check out the complete stack. That's the Atlas, the Centaur, and the spacecraft. We held our flight readiness review this past Thursday, successfully completed that. We also held our launch readiness review this morning and successfully completed that. Today we'll be opening up the doors of the vertical integration facility and get ready for rollout tomorrow of the launch vehicle stack, which will occur about 10:30 in the morning. After that, we will load the RP-1 fuel on the first stage. We'll go home, get some rest, show up real early in the morning, 5 o'clock. About 5:30 in the morning, we'll start applying power to the Atlas and the Centaur. The management team will be on station about 9 o'clock in the morning, and we'll start our cryogenic tanking about 11 in the morning tomorrow. At 1:14, I will do my final launch readiness poll, and I will give the final go for launch tomorrow at approximately 2 minutes and 50 seconds prior to launch for our T0 at 1:24 in the afternoon. With that, I'll turn it back to Bruce.
Okay, thank you, Omar. And now we'll hear from Mike Jensen, who is, again, the Vice President and Chief Technical Officer for the International Launch Services.
Thank you, Bruce. International Launch Services and the Lockheed Martin Atlas program are very excited to have the opportunity to launch the Pluto New Horizons mission for our NASA customer. With New Horizons being the first mission ever to Pluto, we clearly recognize the importance of this mission to NASA. New Horizons will be the second Atlas V launch for NASA and will be the 135th NASA spacecraft flown on Atlas throughout the history of the Atlas program. The Mars Reconnaissance Orbiter mission was the first Atlas V flight for NASA and was successfully launched just 5 months ago in August 2005 here from the Cape. There have been a total of 6 Atlas V missions launched to date, all of which have been 100% successful. In fact, the current Atlas success record is 77 consecutive successful Atlas flights since mid-1993. The New Horizons Observatory will be launched on an Atlas V 551 vehicle configuration designated AB010. The Atlas V 551 has a 5-meter diameter payload fairing with 5 solid rocket boosters, or SRBs, and a single-engine Centaur upper stage. The vehicle is 196 feet in height and weighs over 1,260,000 pounds at liftoff. Total thrust at liftoff is over 2.5 million pounds, of which approximately 1.6 million pounds is provided by the 5 solid rocket boosters. The AB010 vehicle and the Boeing-provided Star 48B third stage will inject the New Horizons Observatory into the desired hyperbolic departure orbit from Earth. After third stage burn and separation, the New Horizons Observatory will be traveling at a speed of 9.8 miles per second, which is, as Colleen mentioned earlier, is the fastest Earth departure trajectory ever flown. There is a unique departure orbit for every day of the launch opportunity, which is from January 11th to February 14th. A single parking orbit with a perigee altitude of 89 nautical miles, an apogee altitude of 116 nautical miles, and inclination of 28.9 degrees will be used through the entire launch opportunity. As a result of this fixed parking orbit and the varying geometry of the interplanetary mission, The Centaur parking orbit coast period and the Centaur second burn sequencing will vary each day of the launch opportunity and throughout the daily launch window. For the planned launch on January 17th, the window is from 1:24 to 3:23 p.m. Eastern Standard Time for a total launch window duration of 1 hour and 59 minutes. To illustrate the Atlas V launch phase of flight for the Pluto New Horizons mission, I'll show an animation of the Atlas flight profile and the nominal sequence of events from liftoff through to New Horizons observatory separation. These event times are for the planned launch on January 17th at the opening of the launch window. So if we can go ahead and roll that video. The AVO-10 mission begins with the ignition of RD-180 engine and the 5 solid rocket boosters to lift off from Launch Complex 41. At liftoff, the RD-180 engine is at full sea level thrust of over 860,000 pounds. Shortly after liftoff, Atlas begins its initial pitch-yaw roll maneuver to attain a flight azimuth of 88.8 degrees. At 5 seconds into flight, the RD-180 engine is throttled down in preparation for maximum dynamic pressure phase of flight. At approximately 27 seconds, the vehicle will begin zero angle attack phase to minimize aerodynamic loading on the vehicle. After passing through maximum dynamic pressure at approximately 45 seconds, the RD-180 engine is throttled up to 86%. At 75 seconds, the RD-180 is throttled down to 75% and is maintained until burnout of the SRBs. The solid rocket boosters will burn out at 1 minute and 34 seconds into flight. At about 12.5 seconds after SRB jettison burnout, SRBs 1 and 2 are jettisoned, followed by 3, 4, and 5 1.5 seconds later. Upon reaching an acceleration of 2.5 Gs at approximately 2 minutes and 38 seconds, the RD-180 engine begins throttling to a constant vehicle acceleration. The payload fairing is then jettisoned approximately 3 minutes and 23 seconds into the mission. 5 seconds after fairing jettison, the Centaur forward load reactor is jettisoned, and then 3 seconds later, the RD-180 engine is again throttled up to 100%. Upon reaching an acceleration of 5 Gs, approximately 3 minutes 53 seconds, the RD-180 engine begins throttling to maintain the constant 5G acceleration. 10.6 seconds before predicted booster engine cutoff, or BECO, the RD-180 is throttled down to a 4.6 constant vehicle acceleration. After Atlas stage propellant depletion, booster engine cutoff, or BECO, is initiated at 4 minutes and 28 seconds into flight. 6 seconds after BECO, the Atlas booster stage is jettisoned, and Centaur main engine start 1, or MES 1, takes place 16 seconds after booster engine cutoff, about 4 minutes and 44 seconds into flight. The Centaur first burn is about 5 minutes and 22 seconds in duration and will inject the vehicle into the desired parking orbit. Centaur first burn main engine cutoff, or MECO 1, occurs about 10 minutes and 6 seconds into the flight and is based on a guidance commanded shutdown. The Centaur then enters a coast period which varies between 8 and 25 minutes depending on the actual launch day and window time. At a guidance calculated start time, the Centaur main engine is reignited for MES 2 and will burn for about 9 minutes and 39 seconds. Centaur MECO 2 will occur based on a guidance commanded shutdown time at 42 minutes and 2 seconds. 10 seconds after MECO 2, spin-up of the Star 48B is initiated. The third stage is then separated from Centaur 3 seconds later. The Star 48B motor is then ignited and will burn for approximately 1 minute and 28 seconds. Observatory separation from Star 48 will occur about 47 minutes, 47 seconds after liftoff. Observatory separation will vary between 34 and 50 minutes depending on launch day and the launch window time. That concludes the Atlas V mission. Thank you, Bruce.
All right, thank you, Mike. Next, we're going to hear from Dave Kushnerkevich, the New Horizons Mission Systems Engineer. Dave?
Thanks, Bruce. I'd like to give you a brief look at the New Horizons spacecraft and description of the early part of the mission. The spacecraft was developed for NASA and built by the Applied Physics Lab at Johns Hopkins University in Laurel, Maryland. After we integrated the spacecraft, we started our test campaign there, part of our environmental test program. Then we moved over to the Goddard Space Flight Center in Greenbelt, Maryland, to complete the environmental test program prior to shipment down here to KSC. If I could have the tape, please. We arrived at KSC in late September. This is the spacecraft coming into the facility here at KSC where we processed it for launch with protective covering over it to guard against dust contamination. There were several components that didn't travel to the Cape with the spacecraft. The swap instrument that you see here was removed from the spacecraft, had the detector refurbished, and then was reinstalled. There you see the test of the cover over the swap detector being deployed. This is a closeout of the rear panel on the spacecraft. That round object was the cover for the LORRI instrument. That was the door with the thermal blanket material on it, the gold cover. Final assembly of one of the top panels of the spacecraft going on. Prior to the final dress out of the thermal blankets. The thermal design of the spacecraft relies on a thermos bottle-like approach where the thermal blankets minimize the heat leak from the spacecraft to keep the internal environment near room temperature throughout the entire course of the mission. All these blankets, of course, are custom fit and very carefully placed, put into place in order to minimize those heat leaks. You can see the blanketing there around the back of the 6.5-foot diameter high gain antenna. While we were here at KSC, we mated the spacecraft for the first time to the flight power source, the nuclear power source. This is the RTG for that initial flight check, the initial checkout of the flight mate. It was mated both mechanically and electrically, after which electrical tests were performed on the spacecraft to verify compatibility between the power source and the rest of the electronics on the spacecraft. This is the spacecraft all dressed out with all the thermal blanketing complete. That is a mass simulator in place of the flight RTG at this point of the operation. And the spacecraft is very carefully lifted prior to all move operations. That was a device that allows us to very gently lift the spacecraft up without shocking it with the crane operations. We're preparing here for the mate to the third stage of the third stage of the launch vehicle, the third stage having been provided by Boeing, which you'll see here surrounded by scaffolding. You can see the large Star 48 motor, the dark sphere in the center there. All of this took place in a facility here at KSC, after which the entire stack of the third stage in the spacecraft was encapsulated in 1/2 of the total fairing that goes on the Atlas V launch vehicle, that fairing being about 17.5 feet in diameter. And again, that's just the top half of the total 68-foot long fairing. The encapsulated assembly was then transported to the facility where it was mated to the launch vehicle. Now, the New Horizons spacecraft weighs about 1,054 pounds. At launch, about 170 pounds of fuel is on board. The entire spacecraft only consumes about 200 watts of electrical power, actually less than that. So that's less power than is required to run 2 100-watt light bulbs in your house. I'd also like to show you the first part of the mission, if I could have the animation, please. This depicts post-separation from the Centaur second stage. The third stage and spacecraft are now separating. We come off the spacecraft at a spin rate of about 60 RPM, or about 1 revolution every second. We then use the propulsion system on board the spacecraft to slow that spin rate down and begin our targeting operations for the Jupiter flyby, which occurs on February of 2007. The Jupiter flyby enables us to accelerate the speed of the spacecraft to allow us to arrive at Pluto in July of 2015. This depicts that flyby operation, getting the Jupiter gravity assist. We will also perform scientific observations during that period. After Jupiter, the spacecraft goes into a hibernation mode for the journey to Pluto, which will take about another 8 years from that point. So, Bruce?
Okay, thank you, Dave. And finally, we're going to hear from Joel Tundiolo, the launch weather officer. Joel?
Thank you. Hello, everyone. Good afternoon. As Bruce said, I'm here to give you a rundown of the weather conditions that are expected over the next couple, 3 days, including, obviously, launch day. As opposed to the summertime where we're dealing with daily afternoon thunderstorms, and as opposed to hurricane season, which seems to last longer every year, This time of the year, we're mainly dominated by fast-moving cold fronts that come through the area. Typically, we see a cold front move through Central Florida every 4 to 5 days, and that's pretty much the pattern we're in right now. For those of you who are expecting warm Florida weather the past couple of days, my apologies. We had a very strong cold front move through Saturday morning with strong winds and cold temperatures. Actually, tonight's going to be the coldest temperatures we're going to experience. The main reason is the winds that we had yesterday and early today will pretty much weaken substantially. And when we have light winds, that means the temperature gets colder at night. We are expecting min temperatures to be in the mid-30s tonight. Not expecting freezing conditions, but we do expect temperatures again in the mid-30s. The good news is once we get beyond tomorrow morning, during the day tomorrow, as the vehicle rolls out to the pad, we expect warmer conditions. The temperature will increase pretty rapidly up to around 70, 75 degrees during the afternoon. And we are expecting no hazardous conditions at the time the vehicle is rolling out to the pad. What we will be watching is the next cold front that right now is expected to come through the area sometime early on Wednesday, and we'll actually see the first effects of that tomorrow as our winds start to shift around to a more southerly and southwesterly direction. Right now they're out of the northwest. We'll see them shift all the way around to the south and southwest as the next frontal boundary approaches us. That's good news in that it warms our temperatures up. And so we'll be looking at that. So again, no hazardous conditions for tomorrow's rollout. As we get into launch day, we'll have a cold front pretty much as I could see the satellite picture up on the TV. That clouds out well out to the west is just the very outer beginning fringes of the next weather system coming through the area. But once we get into Tuesday morning, the cold front will be located over the western Florida panhandle. Different models that we look at have a little bit different location, but on average it's going to be over the western Florida panhandle. And right now we are anticipating no hazardous conditions for launch day. The only thing we will be watching is the ground winds. As that front gets closer, our surface winds will start to increase from the southwest, and we are expecting winds to be in the lower 20s, possibly into the mid-20s, and can even rule out a gust to possibly 30 knots on occasion during the day on Tuesday. Right now that is below the threshold for launch and all that, but we will be watching that very closely. In terms of precip, there may be a few showers around late in the day on Tuesday with that frontal boundary, but right now we're not anticipating that to be a concern for the launch. We are, again, just watching for the ground winds and possibly those clouds that you see well out to the west moving in. Right now we're at a 20% no-go for Wednesday afternoon, with, again, winds and clouds being the main issue. Right now we're forecasting 2 cloud decks, one at around 25,000 feet and another very upper level cloud deck at around 24,000 feet. Again, our winds will be out of the south, 22, possibly gusts of 30 knots, and as I mentioned, 20% no-go. Now, if we were to delay one day, that frontal boundary will again be on our doorstep. Actually, it'll be moving through early on Sunday, so conditions, without saying, will be worse on Wednesday as opposed to Tuesday, as we're looking at a 60% chance of violation of our weather rules on Wednesday if we were to, in fact, need that day, with, again, clouds and winds and precip with the frontal boundary being the main factors. So we're in between cold fronts, and if things stay as is right now, we will remain between cold fronts, and hopefully things will work out. Thank you.
Okay, thanks, Joel. We'll take your questions now. Please give us your name and affiliation and wait for the microphone. Let's start with Mike right here in the front row.
Mike Schneider with the Associated Press. Probably a question for Omar. I was wondering if you could just talk about the discussions during the flight readiness and launch readiness review meetings on the RTGs and whether the risk assessment has changed at all during launch as far as you know, the threat or possibility of a release of plutonium should things not go right.
And Mike, I'll let you know that no, the assessments haven't changed as far as what has already been assessed. There's absolutely no added risk to the mission, so there's no need to change that. We were briefed on the contingency plan that the radiological folks have in place, and that has been exercised and ready to serve us Tuesday if need be. Hopefully not.
Okay, Stefano?
Yeah, Stefano Claudan for Time Magazine. The checks that you performed on the first stage of the rocket, can you explain why do you have to do those to carry them out, and also were they conducted as an extra precaution since you have a plutonium the load on board?
I'm presuming you're talking about borescoping of the RP-1 tank?
Yeah.
Okay. And that all stemmed from a failure they had back at the factory with a qualification tank that was brutally tested and failed and causing us some concern with the hardware that was out in the field. And that opportunity gave us a chance to go look at the tank to make sure, after we had done a wet dress rehearsal and several pressurization cycles, that we had no cracks or any indication of deformation on that tank. And that's why that tank was done, and the tank came out clean.
Okay, Craig?
Craig Cavalt with Aviation Week, and actually I've got a different take on those similar two questions that you just addressed. Is it not true that safety and mission assurance initially came in with a no vote the other day on the Atlas review? And just kind of speak to the specifics behind that no vote, if in fact that was the case, and how you did resolve it in a process.
We've got a process, and safety and mission assurance had their concerns about this qual tank and this lineage on the tank, and through the testing that we've done, the borescoping, if you were to look at how badly this qual tank, or the environments this qual tank saw, and you saw what our actual flight tank has already seen as far as hydro testing and so forth, you come to the realization that we've got a robust tank. We've tested it. We've gone in and inspected it during this borescope inspection. There was disagreement. It did come to a board. The board weighed on the fact that the test tank was tested and it failed. It failed by a little. It was on its last test. The flight tank will never see this environment that the test tank was subject to. The other piece of this is our tank is absolutely pristine. There was no indication of any kind of defects on this tank. So if you want to be in the right spot, you've got a test tank that was brutally tested and just failed by a little. You've got a pristine tank, and a decision was made that with those facts in hand, we're good to fly.
Thank you. Chris?
Hi, Chris Kreidler from Florida Today for Mike Jensen. This is a little spacecraft on a great big rocket. How fast is this thing going to get out of here? What will people see?
Actually, I mentioned the total mass and total thrust at liftoff. Typically, what we call the thrust-to-weight ratio is at liftoff. For a typical Atlas is like 1.15, like 401. This equivalent liftoff thrust-to-weight ratio will be 1.9, so it'll be a very, very fast liftoff and acceleration compared to other flights.
Justin?
Right, with spaceflightnow.com, to follow on that, do you know what the spacecraft G loads, what it will feel at liftoff? And for Joel, could you refresh my memory on what the actual wind limit is for launch?
Well, I can address the total G load, as I mentioned through the animation there. The RD-180 engine is a throttleable engine, and there are various phases of flight in which the engine is throttled to maintain a certain acceleration level, and the maximum through the flight was 5 Gs, as I mentioned. Well, like I say, it's around 2. Yeah.
Okay, and Bill?
Just to follow up on Craig Cavalt's question for Omar, if I could. I want to make sure I understand the purpose of what I guess Atlas calls that an ultimate pressure test, where you go to twice flight pressure or whatever and the tank failed. That is because of 5 SRBs? Was that the motivation to test your structural margin for having 5 SRBs on the vehicle? Is that correct, number one? And number two, what caused the failure on the factory tank? Was it simply overpressurization and fatigue, or did you determine a cause?
Let me try to address it from the beginning. And your first question, did we determine root cause? Yeah, we saw what root cause was. There's a deficient design, and it wasn't caught through the system. If we were to sit down and build a new tank, and there will be a new tank, it will be designed, and the part that was overstressed will be designed to be able to handle that type of load. Now, getting back to what you were asking, the ultimate test. No, with these 5 solid configuration, this was not the worst case that it's going to see. This was to qualify a family of vehicles, not just this configuration. I hope I answered that.
That's fine, thanks.
Okay. This is Atlas Launch Control at T-minus 1 hour 14 minutes and counting, and everything continues to go well today. We have a full load of liquid oxygen on the Centaur stage, and we are about 23% full of the liquid oxygen on the Atlas stage at this point. I have with me right now Dave Kuchner-Kavich, who is the New Horizons Mission Systems Engineer. And Dave, thank you for coming.
Thanks for having me.
We have a tape that we're going to show, and then we're going to come back and ask a couple of questions. So let's
Okay.
go ahead and roll that tape, and I'll let you talk to it.
I think this tape shows some of the processing of the spacecraft that we did once we arrived here at KSC. This is us coming into the facility where we processed. There was a protective covering to guard against dust contamination when we came into the facility. There were a couple of components that did not make the trip down here with the spacecraft. They went to various places, and then they joined back up with the spacecraft here at KSC. You've seen the reinstallation of the SWAP instrument for solar wind at Pluto back on the spacecraft, and now some final panel closeouts. Sort of interesting, you see those projections coming off of the panels. That's to hold the thermal blankets off a couple inches from the structure of the spacecraft, to help protect the spacecraft from damage from micrometeorites during the cruise out to Pluto. And this is a top panel going on the top of the spacecraft with final closeouts at that point. After the panels go on the spacecraft and are secured mechanically, then the thermal blankets are dressed out. The thermal blanketing is very important to maintaining a good thermal environment of the spacecraft during the long mission life. The spacecraft basically uses a lot of the waste heat that's dissipated from the internal electronics to maintain the inside of the spacecraft near room temperatures throughout the life of the mission. Now the thermal blanketing is complete. Everybody takes a step back to admire their work. And this was the first time that we mated the flight power system, the nuclear power source, to the spacecraft. This operation here served as both a mechanical fit check, and at that time we also mated the power source electrically to the spacecraft and then put the spacecraft through a series of electrical tests to ensure the compatibility of the entire flight system. What you're seeing here is a mechanical simulator on the end of the spacecraft in place of the flight power source. We put that simulator in place for lift and move operations of the spacecraft to keep the spacecraft properly balanced so it didn't tip over when we lifted it up, which as you might imagine is a very careful operation. It's done very gently so as not to jar the spacecraft or impart any mechanical shocks into it. At this point, we're getting ready to mate the spacecraft to the third stage, the Boeing-provided third stage with the Star 48 motor. You'll see the third stage there inside that scaffolding, and so the spacecraft was lifted, transported over, and then gently lowered down on top of the third stage, mated together mechanically, and then that assembly was placed inside of the launch vehicle fairing. That's the operation you're seeing here. That's actually just the top half of the fairing that sits on top of the Atlas launch vehicle. The fairing is 68 feet total in length, and this is the portion of it that was transported out to the assembly building to finish mating with the launch vehicle. Good, and of course after the tape ended, of course everything continued to mate it to the top of the launch vehicle, and as of right now, since that time we've been in launch configuration. Dave, tell us a little bit about any issues or concerns that we had. Were there any for the processing of the spacecraft here at Kennedy, or did everything go smoothly? Everything went pretty smoothly. There's always a lot of work involved. There's no getting around that. But thankfully, the operations were pretty smooth. I think the major hiccup we had was when Hurricane Wilma came through. That required us to put the spacecraft back into the shipping container to keep it safe during that period, and the team had to stand down for a couple of days. They had a couple of unexpected days off during that time, but we were able to recover. Fortunately, there was no damage after Hurricane Wilma to the spacecraft, and we had enough time in our schedule that it didn't affect us, the couple days off that we had. Okay, so just one little hiccup, but really no issues as far as processing goes at all. Right. I know the team is you know, it's got a diverse team that you have that you put together to help with this spacecraft processing. Tell us a little bit about that. Well, we did all the spacecraft design work and the development work at APL. The instruments, of course, came from various institutions around the country, including Southwest Research Institute in San Antonio, Ball Corporation in Boulder, Colorado, and a couple other places. It's an experienced team, but as you might imagine, it takes a lot of work and a fairly large-sized team in order to accomplish this. It really helps when everybody knows their job, what has to be done, and a lot of people are basically self-starters. They don't need a lot of motivation. They do need some supervision, but everyone pretty much enjoys the effort. It's a terrific program to be involved with. Terrific project.
Good. And with the spacecraft on top of the Atlas V now, we're not working any issues with it today, are we?
No, things have been very smooth during the whole launch countdown process, and we're looking forward to 1:24 p.m. Eastern Time.
Well, we are too. So thank you for coming and joining us, and good luck to you today.
Thanks, Bruce.
All right, thank you. Again, everything continues to go well at the pad. T-minus 1 hour, 8 minutes, and counting. This is Atlas Launch Control. With us right now, Mike Stelzer, who is the Missions Integration Manager. Mike, thanks for joining us.
Pleasure to be here.
All right, good. Mike, you're going to talk to a short tape of the launch vehicle preparations. So we'll roll that tape right now. If you could just watch the monitor and tell us what's going on here.
Okay, real good. We'll like to walk through how the rocket came together here at the launch site. This is a video of the Antonov transport carrier coming into the Cape Canaveral Air Force Station. This is the transporter used for both the first stage booster, the Atlas booster, and the second stage, the Centaur upper stage. This is a shot of the Centaur coming off the Antonov transporter and moving over to the Spaceflight Operations Center for Atlas V back here at Launch Complex 41. That happened at the beginning of September, and about a week later, the booster came in from Denver on that same transport carrier, and here it's shown being erected out at the launch pad and being carefully lowered onto the mobile launch platform. Once the Centaur finished its electrical checks back at the ASOC, it was moved out to the launch complex to the vertical integration facility, where it also was hoisted in position on top of the Atlas booster. This is a shot of it being raised, and the single RL-10 engine is shown there with the blue protective covering. This is the stage that will take this mission from Earth orbit and bring it planetary trajectory towards Pluto. After it was lowered in place, we brought the 5 solid motors out to the integration facility. This is a video of the 5th of those solid rocket motors going into position and being installed on the forward side of the Atlas booster. Following completion of the installation, we brought the vehicle out to the launch pad, very similar to today, and did a tanking test where we demonstrated that we could safely tank the vehicle and all systems were working properly. Once we knew we had a good rocket, we brought the encapsulated payload, including the New Horizons Observatory and third stage, out to the launch pad. This is a shot of it as it's sitting at the base of the vehicle integration facility, ready to be hoisted up and put on top of the Atlas and Centaur stack. This happened about a month ago, mid-December, and since then we have electrically checked out the vehicle. It's ready for us today, and as yesterday we've re-rolled it out to the launch pad, and we're sitting there counting down, ready for a good T0 later this afternoon.
Great. We're all hoping for that. Everything's continuing on schedule. In fact, we should be launching in just about an hour from now. Can you tell us a little bit about the complex integration of this vehicle? I know there were some aspects that made it a little bit more complex than normal. What was going on there?
Yes. This mission brought together 3 very different elements. Lockheed Martin provided Atlas vehicle, the largest of their fleet, the top of a Delta II rocket, a Boeing third stage, and on top of that we put this small, lightweight, 1,000-pound state-of-the-art observatory. So bringing those 3 items together, making sure each item worked with the other so we could have a successful launch today and trajectory towards that pinpoint location in space 3 billion miles away past the planet Pluto.
Well, it is a long ways away, and I know that it's going to take a very large rocket to get us to Pluto, and of course, this being a very tall vehicle, can you give us a little perspective on just how big it really is?
Yeah, sometimes it's hard to realize how big it is unless you're standing right next to it or have something to judge it against. And and as you see today, it's sitting out on the launch pad, and it's not really anything out there you can judge its height. So the vehicle itself is about 200 feet tall, and so to help give us a reference point, I asked my daughter and son last night what they knew of that was about 200 feet tall that would put this in perspective, and they both responded, "Oh, Dad, that's easy. This new roller coaster, the Shrika, that opened over in Tampa, is 200 feet tall." So here we have a rocket, very tall as the tallest roller coaster in Florida, and hopefully that'll help put it in perspective for.
Well, it certainly does, and this will be somewhat of a roller coaster ride for this spacecraft as we go out past lunar orbit in just about 9 hours, and then past Pluto in about, 13 months? I'm sorry, Jupiter in about 13 months?
Jupiter in 13 months. So, yeah, once again, this will be the fastest moving thing we've ever launched. So we look forward to lighting her off at 1:24 this afternoon and seeing a safe and successful flight.
All right. Well, in just under an hour, we'll be watching that. So thank you very much for joining us, and good luck to you and your team.
Okay. Thank you, Bruce.
All right. Everything is continuing well at the Launch Pad Complex 41. We are at T-minus 48 minutes and counting. This is Atlas Launch Control.
I know we're going to have to wait 10 years to see the pictures of Pluto, but how long do we have to wait to see the pictures of the takeoff?
Well, I think there's a good chance it may be a 24-hour delay right now, Jim Clancy. It's currently they're looking at about 15 minutes from now, 1910 GMT. As you take a look at the pictures live now from the Cape Canaveral Air Force Station right next to the Kennedy Space Center there, the mid-east coast of Florida, and you look at that liquid oxygen bleeding off midway up the Atlas V rocket, you could get a sense of the wind, which is blowing along 30 kilometers per hour in excess of 45 kilometer per hour gusts, which are sort of the red line point at which time they cannot safely launch. And so with those gusty winds, they're sitting and waiting right now. They are otherwise, without any technological or technical problems, standing in the way of this launch and this long 10-year journey. This is the fastest vehicle ever devised by human beings. It is designed to go about 15 kilometers per second once it goes off and leaves the planet, the gravitational grip of Earth. Even with all of that, to make this 4 billion kilometer journey, it will take upwards of 10 years to get to Pluto, the most distant body that we identify as a planet right now, in a place called the Kuiper Belt. So we're watching the weather very closely right now. Good chance they might have to try this one again tomorrow, Jim.
Let me ask you this. You've been talking about the plutonium fuel. That's part of the reason it goes so fast. But anybody actually getting out of the way, getting out of Central Florida as a result of some concerns?
Well, it's interesting. You know, the plutonium issue is an issue that has not sparked a lot of controversy this time. 24 pounds of plutonium there. It is there to power the spacecraft in the distant reaches of our solar system. The sun is simply too faint in order to power the spacecraft with solar arrays when you're talking about in excess of 4 billion kilometers away. And so that using the natural decay of that plutonium will power the 7 instruments that are on there taking pictures and analyzing the atmosphere. There is a 1 in 350 chance, Jim, that a catastrophic accident would occur within the first 40 seconds of launch, and that would cause some concern. But as it stands right now, NASA says it's worth the risk.
Miles O'Brien will be checking back in with you next hour. We'll be right back.
A spacecraft that will travel faster than ever before. So fast, it'll reach our moon in 9 hours. That's faster than Atlanta, Paris. On a regular plane, the launch has been delayed, though, several times, and the next attempt is due in about 20 minutes. The goal is to capture the first up-close images of Pluto and its surrounding moons.
Now, the spacecraft is called New Horizons. Its journey is going to take almost 10 years to complete. While the mission itself is not controversial, the nuclear payload on board is controversial. Miles O'Brien explains.
It is rocket science, but when it fails,
burnout on all 6 solids.
It is a spectacle. And now the launch of the New Horizons spacecraft to Pluto offers another wrinkle. Inside the spacecraft, 24 pounds of plutonium, the most toxic substance known to man.
I wouldn't want to be in Disney World the day of this launch.
Carl Grossman is a journalism professor and a crusader against launching radioactive payloads into space. He worries about the consequences of a mishap during the launch of New Horizons.
If there's an accident on this launch and that plutonium gets out, I mean, 24 pounds doesn't seem like much, but if it's dispersed as fine particles, and people breathe particles, all you need is a millionth of a gram for a fatal dose.
He may sound like a nuclear-age Chicken Little, but consider this. NASA says there is a 1 in 620 chance of a launch pad accident that could spread radioactive material, a 1 in 300 chance overall during the mission.
If I knew I had a 1 in 300 chance of winning the lottery, I might have go to some lottery store after my class today.
We would love to be able to use a different technology if we could in terms
Astronomer Hal Weaver is with the New Horizons mission team. Heat from the decaying plutonium is the only practical way to power the spacecraft. Solar arrays are not an option. The sun is too faint that far away.
I've invited over 200 people to our launch. I plan to be there. My friends and family will be there. I feel perfectly comfortable with the risks associated with the launch of this mission.
Radioactive remnants of spacecraft have plummeted back to Earth before. In 1978, a Russian satellite with a nuclear reactor broke up across the Northwest Territories of Canada. And 10 years ago, another Russian spacecraft with nuclear material headed toward Mars failed after launch. The wreckage fell in Chile's Atacama Desert.
Cancel Cassini now!
There were protests the last time the U.S. launched plutonium aboard the Cassini spacecraft to Saturn. But the launch was trouble-free. Scientists and engineers insist the payoff, stunning images, and new insights are well worth the risk. And maybe the public agrees. The protests this time around have been meager at best.
The exploration of space, the detailed study of the planets, including Pluto and the Kuiper Belt, are going to be some of the things that people look back on as the achievements of our civilization.
Miles O'Brien, CNN, New York.
Well, CNN space correspondent Miles O'Brien joins us now live with more details. Miles, what's the most significant thing we might learn from this mission?
You know, it's interesting. You ask that of scientists, they always say it's the thing that we haven't thought of. But, of course, here's what they think about when they think about Pluto. First of all, they don't think about it necessarily as the last planet in the solar system, as it is the largest or among the largest bodies in this so-called Kuiper Belt. What's the Kuiper Belt? It's basically planet efforts that didn't go so well, stunted planets that midway through their development, for whatever reason, didn't get to the point where they were really full-fledged planets. That is heresy, I know, for some school kids to say that Pluto really isn't qualified as a planet, but really it's probably closer to an asteroid and a comet. So you go there, though, and it's like going into a deep freeze and looking at what the solar system was like at the very beginning, 4.5 billion years ago. What will they discover? What will they learn? What will they know about the constituents of all that is around us? Hard to predict. But we do know this. All that we know about Pluto right now would fit on the back of a postage stamp.
Wow, that's not much data to have, and it sure means everything is open to discovery right now. Let me ask you, the technology on the mission itself, what makes this the fastest spacecraft we've ever seen? Warp drive, if you will. What powers it?
This is as good as you get on warp drive, Jim. What you have here is a payload package that weighs on the order of 500 kilograms. And you have a rocket itself that in total weighs about 500,000 kilograms. So it's basically a lot of fuel pushing something that's very light. And as a result, it can get going very quickly. We're talking on the order of 15 kilometers per second in speed. That's the fastest thing ever devised by human beings. Way, way, way faster than any sort of rifle shot or anything along those lines. 15 kilometers per second. And still, with all that, takes the better part of a decade to get out to Pluto. So that gives you a sense of the distances we're talking about. And this is just our neighborhood in the universe that we're talking about, our solar system.
All right, Miles O'Brien, he's going to be talking us through the launch and everything. We'll be picking things up with you and CNN USA. Miles, we're all looking forward to it. I love these things.
2:30 p.m. is the latest
Yeah, but
scheduled
another 15
launch.
minutes.
Another 15 minutes. We'll be carrying it live.
1 hour, 58 minutes, and counting. This is
Horizons is still waiting on the launch pad, preparing to blast off on a 10-year trip to Pluto. The spacecraft's launch has been delayed several times due to a technical issue and high winds. New Horizons will explore the outer limits of our solar system, focusing on a belt of rocky, icy bodies, of which Pluto is a part. Scientists believe the belt is debris from the formation of the planets more than 4 billion years ago. Well, speaking of high winds, let's now have a timely look at the global weather forecast. Here is Guillermo Arduino at the CNN International Weather Center. Guillermo.
Hi. Fionnuala, you know, it's going to continue to be a little bit windy there in Florida. So we see those pictures and we don't see any relief at all for the winds. They're not going to go, I think. Now,
SMD, NLM on Launch Manager.
This is SMD.
Yes, sir. Are you configured for launch?
The spacecraft is configured for launch. New Horizons is go.
Copy that. New Horizons is go.
T-minus 3 minutes.
T-minus 3 minutes and counting.
Doing Atlas LO2.
Atlas tanks to flight pressure.
Minus 250. Just internal. Minus 245.
This is LD, NASA New Horizons are go for launch.
Roger.
Flight control no-go. Flight control no-go at T-minus 2 minutes 34 seconds to a red line monitor fault.
Roger, launch conductor no-go.
And we have a abort.
All stations LC when we're in Appendix R, page 129. Flight control went no-go at T-minus 2 minutes 34 seconds due to a red line monitor fault. Roger.
LC is red line monitor.
Go ahead.
Roger, Golf, Charlie, Quebec, 16 uncle and 15 uncle. The liftoff ratios triggered inside the terminal count.
Since this was going to be the end of the window, we are now scrubbing for the day, and we'll recycle for a 24-hour turnaround.
Roger.
About New Horizons, which was due to be launched by NASA at any moment now. You're looking at live pictures, but what we're hearing is that because of high winds and a technical issue, what you can see now on our screen, Pluto launch will be delayed until tomorrow. Several times throughout the day, we have been getting updates that it will be launched every 20 minutes or every half hour or so, but clearly the NASA managers there deciding that Pluto mission will now
40%, also due to strong winds, because this front will be making its way across the Florida Peninsula, and the timing on how quickly or how early or how late that front will move through here is still, you know, quite uncertain, and that are worried. And to quote the launch forecast here, they're saying gusty winds up to 60 kilometers per hour, thick clouds, cumulus clouds, and possibly an embedded thunderstorms. And those are the things or the causes that launch could be scrubbed again tomorrow. Just another word about the U.S. right over here across the Northeast, also looking for some pretty nasty weather over the next day or so, mostly in the form of rain, but some very windy conditions across much of the Northeast. All of it looking better, though, as we head into Thursday across much of the eastern half of the nation. So we'll keep you posted and see what happens with that tomorrow. Well, as we head...
This 10-year trip to Pluto that we told you about yesterday at this time was actually scrubbed a few hours ago because of strong winds and other factors. NASA says it will try to launch the spacecraft again on Wednesday. When it gets into space, it will become the fastest spacecraft ever, reaching the speed of 47,000 miles per hour. Back live with a view of the vehicle sitting at the pad this morning. The vehicle will lift off with a total of 2.5 million pounds of force. And after third stage separation, the New Horizons payload will speed away from the Earth at about 36,000 miles per hour.
LC, Range Coordinator 1.
Go ahead. We have received a go from the range for a T0 of 1900 Zulu.
Roger.
This is Atlas Launch Control at T-minus 4 minutes and holding, and the range has just called the launch director and indicated that our clouds have in fact cleared sufficiently enough so we can continue targeting a launch at 2 o'clock Eastern Time today. We will continue to monitor these clouds in real time in case there is any additional cloud cover that comes over the pad, but at this point we are green, good to go from all weather fronts, and there are no technical issues being discussed at this time, so in less than 10 minutes we should see the liftoff of our New Horizons spacecraft toward the planet Pluto. Coming up in about a minute and a half will be another poll by our launch manager, and that will be conducted to make sure that during this brief delay that all aspects of the launch team are indeed ready to support. So that should be coming up in about a minute and a half. At T-minus 4 minutes and holding, this is Atlas Launch Control.
NLM NEP with our final launch poll to release the hole at T-minus 4 for a 1900 Zulu T0. NASA CE.
NASA CE go.
NASA MEM.
NASA MEM go.
SMA.
SMA go.
SMD.
SMD go.
NAM.
NASA advisory team's ready.
NASA is ready to release the hold at T-minus 4 minutes.
And Omar Baez, our launch manager for this mission, again conducting his poll, and all aspects of the launch support team are reporting in that they are ready to pick up the count. We are at T-minus 4 minutes and holding, and that count should be picking up in about 3 minutes and 10 seconds, giving us a launch time of 2 p.m. Eastern Time.
Status check for continuing the countdown. Umbilical retract. Go. Atlas LO2. Go. Atlas propulsion. Go. Atlas hydraulics. Go. Atlas pneumatics. Go. Centaur engine chill. Go. Centaur pneumatics. Go. Centaur LO2. Go. Centaur LH2. Go. Has gas systems. Go. Airborne electrical. Go. RFFTS. Go. Flight control. Go. Instrumentation. Go. Communications. Go. GC cubed. Go. Ground electrical. Go. Facility electrical. Go. Environmental control system. Go. Range and weather and final clear to launch. Go. Quality engineer. Go. Up safety manager. Go. LM safety officer. Go. Redline monitor. Go. Launch director.
Launch director is go for launch.
T0 is planned for 1900 Zulu. Set count to start at 1856 Zulu.
T0 is set for 1900 Zulu. Count will start at 1856 Zulu.
LC BTC, com check, channel 1.
Loud and clear BTC.
And we have 1 minute remaining in our hold, and the range has
Stand by to
reported
pick
that
up the
they
count.
are
1
still
minute.
go. Picking up the count in about 45 seconds.
On my mark, time will be T-minus 4 minutes and counting.
Picking up the count in 10 seconds.
3, 2, 1, mark. T-minus 4 minutes and counting.
Minus 3 minutes, 55 seconds.
Ground pyros enabled.
And we have indeed picked up the count. T-minus 3 minutes, 45 seconds and counting, and all is going well at this point in the countdown. NASA's New Horizons mission to the planet Pluto is about to be launched. It's a 10-year journey to the outer planet with a swing-by of Jupiter on the way. New Horizons will be traveling between 28 and 30,000 miles per hour, passing our moon's orbit in just 9 hours. The probe will get a gravity assist as it flies by Jupiter, kicking the speed up to 47,000 miles per hour. T-minus 3 minutes and counting.
Securing Atlas LO2.
Atlas tanks to flight pressure.
Minus 250.
There are no launch constraints, no weather launch constraints. Everything is green and looks good to go.
LD, NASA, New Horizons are go for launch.
Roger.
T-minus 2 minutes and counting.
Minus 1 minute, 59 seconds.
Vehicle internal.
55.
Launch sequencer start.
Minus 150.
Securing Centaur LH2.
Securing Centaur LO2.
Minus 140.
Launch enabled.
Minus 137.
FTS armed. Orca's armed.
Minus 125.
LC third stage SNA armed.
Roger.
Minus 120.
FCS count started.
Minus 115.
Reduce ECS for launch. Roger.
Minus 110.
T-minus 1 minute and counting.
Minus 55 seconds.
Third stage is go.
Roger.
T-minus 45 seconds.
Minus 40 seconds.
Stable at step 3.
Minus 29 seconds.
Dow's locked.
ECS reduced for launch.
Roger.
Minus 25 seconds.
Status check.
Go Atlas. Go Centaur.
T-minus 18. 15 seconds. 11, 10, 9, 8, 7, 6, 5, 4, 3, 2.
You're looking at a launch pad at Cape Canaveral. There it goes.
NASA's New Horizons spacecraft on a decade-long voyage to visit the planet Pluto and then beyond. T plus 15 seconds. Everything continues to look good as the Atlas V vehicle climbs away from Florida's east coast. The 5 solid rocket strap-on boosters are burning just fine, sending the New Horizons spacecraft on its way to the very edge of our solar system. T plus 35 seconds. T plus 40 seconds.
Let's listen now as CNN's Miles O'Brien describes this mission.
Certainly the weight of the world on the shoulders of the scientific team there as they launched it, especially with that plutonium on board. The first 40 seconds were considered the most of concern for a problem which would have potentially released radioactive debris on the Florida coast. By now, it is long over the Atlantic Ocean, and thus, even if something bad happened now, it would not pose a threat to any people. So the critical part of the launch from that perspective is over. Of course, the long, arduous mission to Pluto lies ahead, and what you're seeing right now, though, Kira, is acceleration toward the fastest speeds ever attained by a human-made object. And there you see those boosters coming off, 5 of them. Always reminds me of, you know, when you're driving on the highway and you see somebody toss a cigarette outside of the window, and there off went the cigarettes.
Boosters, a lot more fire on the end of a booster there.
Yeah, you could say that, but that rocket has given up the butts there on its way toward a very fast journey to Pluto, which will
10
still
years,
take
right?
10 years, because we're talking 3 billion miles, billions and billions of miles in order to get there.
And when it gets there, the purpose being, what do those at NASA hope to achieve?
Well, here's the
and you
thing,
wonder, too, those that are involved now, Miles, will they be there 10 years from now? They might be retired, sitting back, looking to you to tell them what happened.
Exactly. By that time, we may have discovered several other bodies of the same classification of Pluto. Pluto may no longer be considered a planet, which is, there's a lot of discussion in astronomical circles about that. In other words, it launches to a planet and arrives at a glorified asteroid. In any case, what's very interesting, I think, about this, we talked about this yesterday, or whatever day it was, the day before yesterday. They have basically 36 hours in which to perform the main science at Pluto. It's a flyby mission. There's not enough rocket fuel on board for it to slow down and orbit Pluto. And so they, you know, imagine if they forget to take the lens cap off during that 36-hour, you know, I say that in a symbolic way, but the fact is everything has to be just right. After a 10-year period, you see the additional boosters coming off now.
Who's operating all the cameras?
All right, we've been listening there to Miles O'Brien talking with Kira Phillips, describing a mission to the outer reaches of our solar system and the planet Pluto and its moons. There are 3 moons around Pluto. It's going to be making, as Miles described there, just a flyby. And think about it, perhaps 10 years from now or so, you can say that you were watching live television, saw this take off, and it's really going to reveal secrets. It's going to reveal elements about Pluto, if it succeeds, that none of us have ever known before. No one knows what is out there at the edge of the universe, where all of these blocks of ice and everything form a belt. And it's been called the primordial elements of our solar system. The things that are out there date to the formation of the solar system, and it should be really a treasure trove for scientists. And you and I were able to sit here alongside Hala and watch that go up today. Might be 20 years before we see this thing again.
And maybe we'll be sitting in these very seats.
I doubt
talking
it.
about it.
In my case, I doubt it.
Okay.
11, 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have ignition And liftoff of NASA's New Horizons spacecraft on a decade-long voyage to visit the planet Pluto and then beyond. T plus 15 seconds. Everything continues to look good as the Atlas V vehicle climbs away from Florida's east coast. The 5 solid rocket strap-on boosters are burning just fine, sending the New Horizons spacecraft on its way to the very edge of our solar system. T plus 35 seconds. T plus 40 seconds. One minute into flight.
Boosters throttle back to 75% thrust. SRB chamber pressures continue to look good. And SRB4 is burning out, and all chamber pressures are responding. And we have BOTA, RD-180s throttling up to 100% thrust.
T plus 1 minute 45 seconds. Everything continues to look
solids
good.
1 and 2,
Boosters
3,
have
and
just jettisoned.
4, 5. Solid separation looks good.
Main stage still running fine. T plus
Vehicle
2 minutes
stern's
and
been enabled,
counting.
right on time. Vehicle attitude rates look good.
Start ground system securing.
Vehicle is currently flying at 33 nautical miles in altitude, 39 miles downrange, at a speed of 4,780 miles per hour.
Status check for pad entry.
Booster bus and battery voltages are stable. Tank pressures are good.
Atlas propulsion. Ready. Atlas hydraulics.
Next event will be firing the RCS pyro valve, pressurizing that system for flight, and throttling to maintain a constant 2.5 G acceleration.
Centaur LO2. Ready. Centaur LH2.
Ready.
Has gas systems.
And we fire the pyro valve.
FTS. Ready. Facility
And we've
electrical.
done throttling
Ready.
to maintain a constant 2.5 Gs. System's pressurizing normally for flight level. Vehicle's currently at 50 nautical miles in altitude, 59 miles nautical miles downrange at 6,800 miles per hour. Range track looks good, right down the middle of the track.
Launch plus 3 minutes.
20 seconds to payload fairing jettison. Vehicle currently accelerating at 2.6 Gs. We have boom ordnance firing. We have payload fairing jettison, 2 good brake wires, and CFLR deck jettison. Booster has begun to throttle to 100% thrust. This will be followed by a 5G throttle segment momentarily. Vehicle is currently at 67 nautical miles in altitude, 78 nautical miles downrange, flying at 9,800 miles per hour. We've begun accelerating to 4.8, 5.0 Gs. 5G throttle segment looks good. Boost phase chill down has begun. RL10 pump temperatures look good in response to chill down. We've begun throttling to 4.6 Gs in preparation for BECO. Boost phase chill down is complete. And we have BECO. Engine shutdown looks good. We have retro rockets and stage separation, clean separation. We have LOX and fuel pre-start. We have the GN2 purge firing. We have ignition and full thrust on the RL10. Centaur steering has been enabled, correcting out some small attitude rates from separation. Centaur PU has been commanded to fixed angles for the early portion of this 5-minute and 23-second burn. RCS line temperatures look good in response to our warming firings. Centaur is currently flying at 93 nautical miles in altitude. Downrange distance is 591 miles. The speed is currently 14,545 miles per hour. Range track looks good right down the middle corridor. Centaur tank pressures are stable. Helium storage bottle pressures look good. Bus and battery voltages are good. Centaur operation continues to look very good as we approach closed loop control portion of the Centaur burn for the Centaur PU. And the PU has gone to closed loop control, however it continues to request an oxidizer-rich mixture ratio. This is expected for the majority of this first burn. Centaur tank pressures look good. Storage bottle pressures are good. Bus and battery voltages are stable. Centaur has begun its roll to optimize vehicle telemetry. Roll rates look good. Expecting the format change momentarily. And we've had the format change, just a small drop in data. Data quality looks very good at this point in the mission. And we continue to see the appropriate signatures and levels on the RCS system in response to the warming firings. Engine operation looks nominal. Chamber pressures are good. Pump discharge pressures look excellent. FTS AGC signals look good. Strong signals. Centaur operation continues to be very nominal. Two minutes remain in this first burn of the Centaur. All systems look very good at this point in flight. Centaur is currently flying at an altitude of 110 nautical miles. Downrange distance is 13,770 nautical miles. Speed is 16,234 miles per hour. Vehicle range track continues to look good, flying right along the predicted flight path. Our all-10 engine performance continues to look very good. Chamber pressures are good. One minute to MECO. Centaur is currently at 110 nautical miles in altitude, 1,628 nautical miles downrange, flying at a speed of 16,852 miles per hour. And we're about 30 seconds to MECO at this point. Centaur PU continues to control on the oxidizer-rich side. Engine operation looks very good in response. And we have main engine cutoff. Engine shutdown looks good. We have 4S settling. Hydrogen tank pressures are being vented as expected. Bus and battery voltages are stable. Storage bottle pressures look good. And we have RF disable on the Centaur as well. Centaur has begun its turn to the MES 2 attitude and has begun its 1 degree per second PTC roll. This will continue for the duration of this 19-minute and 45-second coast. And we have data return at this point. Data signal looks good. And Centaur continues to settle with 4S thrusters. In about 50 seconds, it should begin to ramp down to a 25% duty cycle. At this point, RCS looks to be operating nominally.
Okay.
Tank pressures are good.
Got it. Thank you.
Storage bottle pressures are good. Bus and battery voltages are good. Vehicle attitude rates look very good. Continuing to roll at 1 degree per second.
This is Atlas Launch Control at T plus 15 minutes, 30 seconds, and counting, and everything went well with our launch ascent phase for the New Horizons spacecraft as it's being pushed out toward the planet Pluto. At this time, we're in a coast phase that will extend to T plus 32 minutes for another, roughly another 15 or 16 minutes. And during this time, we are going to be showing some replays of our successful launch of the Atlas V rocket and the New Horizons spacecraft. We have about 11 views that we'll be showing you, so that will be coming up next, and then we'll be coming back in about 15, 16 minutes for further activities with the start again of the Centaur second stage. We will be listening to live telemetry call-outs as they occur in real time.
Bus and battery voltages are stable. Quick look at the parking orbit parameters. Perigee altitude looks to be within 0.2 of a nautical mile. The apogee attitude is right on, and inclination is within 1/10 of a nautical mile. Centaur RCS continues to ramp down to the 25% duty cycle. Signatures look good. Vehicle attitude rates look good. Continuing to roll at 1 degree per second. And Centaur has begun its roll reversal. This is expected during the coast period. We'll begin to roll in the opposite direction. Currently experiencing a loss of signal. There we go, we've picked it up again. All systems look very stable at this point in the coast. And Centaur has established 25% duty cycle now on the RCS. Signatures look good. Temperatures look good as well. Data quality is suffering a little bit at this point. Getting very near our switch to TDRS at this point in the mission. And we're expecting the switch to TDRS to occur any moment now. And we have data again. Data quality looks very good at this point. Data continues to be intermittent, actually, at this point. But RCS continues to pulse at a 25% duty cycle. Vehicle rates look good. Continuing to roll at 1 degree per second in the negative direction. Five minutes remain in this coast period. Second burn duration will be approximately 9 minutes and 32 seconds in duration, followed by a short 13-second coast until the Star 48 is separated from the Centaur vehicle. And Centaur has begun 4S settling in preparation for the NES-2 start sequence. Centaur rates continue to look good. Tank pressures are stable. Storage bottle pressures look good. Bus and battery voltages are nominal. And Centaur has begun to arrest its PTC roll in preparation for the MES-2 start sequence. And now Centaur is performing a roll maneuver to increase our telemetry coverage. And Centaur has achieved its antenna pointing attitude. All systems look stable as we approach 2 minutes to MES-2. And Centaur tank pressures are being increased in preparation for the start sequence. Pressure rise rates look good. One minute to MES. And Centaur has gone to dual branch hydrogen pressurization. And we have fuel pre-start. This is a 25.4 second pre-start. And we have LOX pre-start. We have ignition and full thrust on the Centaur. Engine performance looks very good. Chamber pressures are good. Pump discharge pressures are good. Turbine pressures are good.
This is Atlas Control, and we have ended our replays, and we are now showing a live video display of real-time events as they are occurring with the Centaur stage and the third stage and the New Horizons spacecraft.
Hydrazine line temperatures look good in response to burn-off and thermal conditioning firings. Engine performance continues to look very good. Chamber pressures, pump discharge, venturi pressures are all nominal. PU has started to control towards a more nominal mix ratio at this point, having corrected out the mass error. Centaur attitude continues to be very good. Rates are stable right down the middle. Continue to see normal signatures and levels in hydrazine currents and temperatures. System performance looks very good. PU is controlling very near nominal at this point in the burn. Engine performance looks excellent. And Centaur has completed its hydrazine burn-off maneuver. Centaur PU is controlling near nominal. Engine performance is very good. Tank pressures are good. Storage bottle pressures are nominal. Bus and battery voltages are stable. Centaur PU is continuing to control very near nominal mixed ratios at this point. Very light RCS responses during the burn. Centaur engine performance continues to be very good. Chamber pressures are stable. Discharge pressures, venturi pressures are nominal. Centaur PU is requested in oxidizer-rich condition. All Centaur systems continue to look very good at this point in the mission. Engine operation is very good. PU is controlling right down the middle. Continue to see the appropriate signatures on the RCS motor firings. Levels and durations look good. Data quality is excellent at this point in the mission. Engine operation continues to be nominal. With a little under 4 minutes remaining in this first burn, all systems continue to be nominal. Engine performance is looking very good. Vehicle attitude rates look very good, controlling right down the middle. Bus and battery voltages are stable. Storage bottle pressures look very good. Tank pressures are stable. Three minutes to MECO. RCS continues to show appropriate responses for our thermal conditioning firings. Engine operation looks very good. PU is controlling right down the middle. Nominal mix ratio. Mass error is 0. 2 minutes to MECO, and all Centaur systems are looking very good. Engine performance continues to be excellent. Chamber pressures are stable. Pump discharge pressures are good. Venturi pressures are good. Turbine inlet temperatures are where you'd expect for a nominal mixed ratio. TU's controlling right down the middle. Engine operation continues to look very good. All Centaur systems are very stable. One minute to MECO. Vehicle performance continues to look excellent at this point in the mission. With just about 30 seconds remaining till MECO, the PU has been commanded to fixed angles in preparation for shutdown. And we have MECO. Engine shutdown looks good. We have 4S settling. We have spin table operation. And we have spacecraft separation and observatory operation.
This is Atlas Launch Control, and we have a successful spacecraft third stage separation from the Centaur stage. Coming up next is the burn of the third stage. That should occur in the next couple of minutes.
Our next event will be a third stage ignition of the Star 48 motor. And we have ignition. Chamber pressure's up, looking good. And our P3 aircraft can also confirm third stage ignition. Thrust chamber pressure still looking good. Data quality looking very good from Diego Garcia. And our spin rate looks right. Picking up a normal mutation signature at this time. Chamber pressure still looking good. Data quality still very clean. NCS system is reacting, picking up some jet fires now. Still looking at very clean data from Diego Garcia. And there's burnout. Third stage has burned out. Looks like a nice signature there. And our P3 aircraft over the Indian Ocean also confirms burnout. Still seeing normal levels of mutation. And the next event we're looking for is the start of the NCS blowdown. And it looks like we had 8 NCS jet firings during the last activity. Data quality is still looking good. NCS tank pressure is at the right level. Starting to pick up just a little bit of noise on our data at this time. Third stage data still looking nominal. Once again, we are expecting the NCS blowdown momentarily. And there it is. We've initiated the NCS blowdown, depleting the hydrazine system. The normal decay signature on the NCS tank pressure, as expected. We've entered the vapor phase of blowdown. NCS blowdown is nearly complete. Picking up a little bit of noise on our data. And we have spacecraft separation. And Yo-Wait deploy. So New Horizons have a safe 9-year journey and a very successful mission at Pluto. And we also have confirmation from the P3 of spacecraft separation.
This is Atlas Launch Control, and we have confirmation of spacecraft separation. NASA's New Horizons spacecraft has begun its journey to travel the length of the solar system. The spacecraft will travel the distance to the moon in about 9 hours, reach beyond the orbit of Mars in 3 months, and take advantage of a planetary boost from Jupiter next year as it heads to Pluto, with a scheduled arrival date in the summer of 2015. Okay, well, everything has gone well today, and I'm glad to have Omar Baez with me right now, who is our NASA launch director, launch manager for this mission. And I know it's been a very hectic 3 days for us here, Omar, but it's an exciting mission. You know, everything has gone well so far. We're sending a spacecraft out to the edge of our solar system. Were there any particular difficulties that we had to get over today, or even the past 3 days that were outstanding in your mind?
Bruce, it's like the last 6 months have been difficult, but I'll tell you, in the last 3 days, there were things that we were dealing with that were beyond our control. Mother Nature got a hold of us. Weather on the first day, nothing we could do about that. The winds were exceeding our limits for being able to fly. And yesterday, Mother Nature got us in the Baltimore area with knocking out power at APL, so not much we could do to help that. We struggled through it early on today with clouds, and the observers from the range that have to have a clear view of the vehicle as it rises in that first 20 seconds. We're having trouble getting that solution. So again, it was Mother Nature holding us back, but we got through it. It was challenging, and we got it, and the vehicle looks to be where it needs to be.
Well, that's good, and that was my next question. How did the vehicle perform today? Are we looking at, obviously a successful spacecraft separation, but overall, how did the vehicle perform?
The vehicle appears to be in the right place where it needs to be to rendezvous with Venus and Pluto 9 years from now, so we are looking really good.
Okay, excellent. Now that we've got New Horizons off the ground, it's on its way to Pluto. It's going to take us 9.5 or so years to get there. It's basically out of our hands right now.
That's right.
What's up next for the launch team here?
The launch team transitions into Pegasus mode, and we go do the Space Tech 5 mission out at Vandenberg, and we're scheduled to launch that February 28th.
Great, and I know you had a great launch team here. Everybody's very excited that we got this one off the ground. I know there was a little kind of nip and tuck with the clouds today, but it's all been successful, and of course we had plenty of weather to work with. Thank goodness. Sometimes we only have a minute or so to work with, but we had a good launch, and we're very excited about this entire mission. So, Omar, thank you. Congratulations to you and your team, and I think we're going to see you here in about an hour or so at a press conference.
Thank you very much, Bruce.
All right, Omar.
Appreciate it.
Thank you. And welcome this afternoon to the Kennedy Space Center for our New Horizons post-launch press conference. I'd like to introduce the folks that will be with us today. Andrew Dantzler, who is the NASA Director, Solar Systems Division. Omar Baez, who is our launch manager for today's launch activities. Alan Stern, the New Horizons Principal Investigator. And Glenn Fountain, the New Horizons Project Manager. We'll begin with opening statements from each of these, and then I'll be happy to take your questions. So let's start with Andrew.
Thank you. Okay, this week, NASA has accomplished an amazing 1-2 punch of planetary exploration. Earlier, a few days ago, we returned the Stardust spacecraft after visiting a comet perfectly successfully, and now, as you just saw, we were able to launch this beautiful Atlas V rocket with the New Horizons spacecraft on it, on its way to Pluto. Everything looks great, and I just have to say that it's been quite a week and quite a past several years getting all this pulled together. I have to point out that getting the New Horizons spacecraft together and ready to go and launched has been a phenomenal textbook example of teamwork. We've had multiple agencies, NASA, Department of Energy, FEMA, EPA, on and on, working hand in hand together to pull this together. I'll leave it to others to mention all the others. There have been so many, but I have to tell you that watching this team work together has just been, it's been a wonderful, wonderful experience. I don't want to take up all the time gushing. I'm sure you all know it was a beautiful launch, and it's just hard to contain myself. But I do want to point out that we talk about how fast this spacecraft is. But by the time you see this, if you watch on the East Coast, you see this news report at the 11 o'clock news, the spacecraft will already be past the orbit of the moon. So I'll just leave it with that. It's been a great day.
All right, thanks, sir. Now, Omar Baez, the NASA launch manager.
Thank you, Bruce. Got one thing to say. 36,256 miles an hour. That's how fast we're going. As Andy said, this is a team effort, and the team pulled it together. There's one player in that team that we can't control, and that's the weather. And it lined up for us at the right time today, and we were able to do it. Not when we expected to, but later on in the day. And that's what occurred to us 3 days ago, or 2 days ago, and it occurred in Baltimore yesterday to slow us down a little bit. We had a great count today. We were able to do our launch countdown management just right and be able to adjust to what the weather conditions were doing to us. And the spacecraft is where it needs to be and going at the right speed and in the right direction. And with that, I'll turn it on over to Chris.
Okay, thank you, Omar. And Alan Stern, the New Horizons principal investigator with the unofficial mascot, I see.
Yeah, yeah. The United States has a spacecraft on its way to Pluto and the Kuiper Belt and then the stars. This is a really historic day, and I have to say, only the United States can do this. I'm very proud of that. The technology and the teamwork that's involved is almost incomprehensible. If you're not actually involved in a project like this, it's very hard to appreciate how hard people work, how many different people, thousands of people across the United States and their families had to support us for years to lift us to the Kuiper Belt. And so my first thanks go to all those people that worked on New Horizons. I want to mention a few particular organizations, Lockheed Martin and Boeing, that gave us such a fantastic launch today, straight down the middle of the pike. APL, which I've been calling the Assured Pluto Lab since 2001, and their spacecraft, as you'll hear from Glenn Fountain, is just doing a spectacular job right out of the box. All of our contractors, the NASA centers across the United States, and especially to Mike Griffin and the team that leads NASA. I want to say that this was a textbook operation for a nuclear launch from the get-go. Safety always came first. Good engineering rationale trumped everything. And I don't have enough words, enough thanks for the work that everyone from the administrator right down to the folks that that helped write the proposal to begin with have done. I really am almost speechless. I do want to point out one little tidbit. You know, I have July 14th, 2015 emblazoned on my calendar. That's our arrival date at Pluto. We are now quite certain of that. I'll point out, it's an interesting happenstance that it will be to the day, the 50th anniversary of the Mariner 4 flyby of Mars, the first Mars mission flyby that really opened the reconnaissance of the planets beyond Earth. And with that, I'll pass it back to you, Jim.
Okay, thank you, Alan. And now Glenn Fountain, who is the New Horizons project manager.
Good afternoon, thanks. Well, we got the launch off at 2 o'clock Eastern Time, and at 2:50 from Canberra in Australia, we received the first signals from the New Horizons spacecraft, and the telemetry all indicates that every system is go. At that point, we had 180 watts out of the RTG. It will build up to about 240 over the next few hours, and will provide over 200 watts when we get to Pluto in 2015. A very good amount of power that will allow us to operate the spacecraft very well. All the systems on the spacecraft are what we call in the business, they're green. They're in good shape. I want to also take a moment to make another couple of points. I think this is the 60th anniversary or thereabouts of a trip that had the speed record from the East Coast to the West Coast that Howard Hughes did. Well, this spacecraft we get from the East Coast to the West Coast in 5 minutes. So that's the kind of speed that we're enjoying as we go out, and yet 9.5 years to get to Pluto. Gives you a sense of the distance to be traveled. We are also at the bicentennial of the Lewis and Clark expedition, and I was asked some time ago how I would feel when we got this thing off. And I thought the words of Captain Clark when he and his expedition arrived at the Pacific Ocean were very appropriate. He said, "Oh, the joy, ocean in view." Well, it's oh, the joy. New Horizons is safely on its way.
Thank you. Great. Thank you. All right, we'll take your questions, and please wait for the microphone. Give us your name and affiliation. We'll start on the front row with Jay.
Jay Barbary with NBC. Dr. Stern, thank you for reminding us that Pope Gregory gave us a century calendar, 2015, July 15th now instead. I believe it was July 3rd. Is that what you said you put on your calendar?
July 14th.
July 14th?
Yes, sir.
Now, could you tell me precisely where the Kuiper Belt is? I've read several articles, and it has it beyond Neptune before you get to Pluto. Is it on the outside of Pluto, or the majority of the time? Exactly where does it fit into the solar system? And a second part of the question, when will we get the information we need to write the final chapter for our school children of our solar system? How long will it take you to get the information once New Horizons is there?
All right, let me take those in turn. First, the Kuiper Belt rings the outer solar system, roughly in the plane of the planets. It's a fat belt of material. And because the orbits of the Kuiper Belt objects, Pluto included, are typically quite eccentric, much more egg-shaped orbits than the orbits of the planets, the objects range over a great distance. Some of them penetrate inside of Neptune's orbit. Pluto's an example of that. Part of each of its 250-year circuits, it spins inside of Neptune's distance. And then these objects have farthest distances, what are called aphelia, that can go out more than twice as far as Neptune's orbit. So it's an enormous structure ringing our outer solar system. With regard to data transmission, we'll be sending home data as we approach Pluto. Every day that we take data, we'll be sending data back. That's our plan. Up until just a few days before closest approach, at which point the amount of data that we take is more than we can afford to send home. We don't have the time because we need to take the time to make the observations. And we'll fill up our solid-state memories during that intensive period and spool it back over a period of weeks and months following. We'll first transmit all the data in a compressed way, which will take about a month to get everything home, and then we'll send it back losslessly compressed. And that'll take a number of months to get back. But I want to just say one thing. I don't think that the final chapter in the exploration of the solar system will be written by this mission. One of the revolutions in planetary science is we're realizing just how much there is to the deep outer solar system, and I think we need more missions, more ground-based exploration, and I think the 21st century is going to be a bonanza for the study of the deep outer solar system, learning what the geography of our home solar system is. And I'll close that off by just saying I think it's exciting that textbooks have to be rewritten over and over. That's one of the really great parts of being a scientist, is seeing your view expand.
Great, thank you. All right, let's go to Kevin right here on the second row.
Oliver with WFTV in Orlando. What are the risks and dangers that you face now that you've made it past the launch between now and 2015?
Yeah. Well, like any mission, the spacecraft has to stay in good health. One of the good things about getting a spacecraft off the planet, it's now in its natural territory, if you will. And I was remarking to Alan as we went through the countdown that we'll finally get it out there where it'll be safe, because it'll be safest on its way to Pluto. We will have a mission that'll continue to go. We've got plenty of power as we get toward the end of the mission, but this is going to be well beyond Pluto. As the power margins drop down, we will then have to be smarter and clever about how we operate the spacecraft. But in general, the spacecraft is now in the safest place it could be, on its way to Pluto.
Great, thank you. All right, let's bring it over here. Let's go with Mike here on the front row.
Mike Snyder, Associated Press. Dr. Stern, I think you said yesterday issues usually pop up, even though there might be pretty small issues, during the first day of spaceflight. And what kind of issues are you going to be on the lookout for tomorrow during the first day?
To my knowledge, the spacecraft is just flying a textbook first few hours of its mission, and we're not working any problems, are we, Glenn?
No, we're not.
No. We were very happy to see that during the launch that the spacecraft took very good care of itself, and the early telemetry showed that there were no recorded anomalous events. Our onboard fault protection system didn't log any faults that it encountered during launch whatsoever. And of course, for all we can test it on the ground, piece by piece, vibration, acceleration, going to vacuum, etc. This is the first time and the only time that it had to actually go through all those at once. So it's now our job to be good stewards of the spacecraft and to get it checked out and on its way to Pluto and to learn to fly it in the real environment, as Glenn said, that it was built for.
All right, thank you. Chris, right here.
Chris Kryler from Florida Today for Dr. Stern. First, congratulations. And was the suspense killing you at all today, or have you sort of mastered the art of patience at this point? And can you recount any special moments you remember from today?
It was suspenseful. There's no question. The weather added the suspense, but seems like every time we got inside of 3 or 4 minutes, you know, I could feel I was getting a little exercise right here. I will say that this has been our project mascot for a long time, this little ground down pencil. And it represents perseverance to get this project underway, to get it built, to get it launched, and now to get it to Pluto. But I'll say the launch team showed a heck of a lot of persistence and very professional behavior as they had to recycle and recycle. I may have lost count. I think it was 5 recycles today. And in fact, just before we walked over here, I presented Omar with one of these pencils for what his team did. So.
All right, thanks. Maybe on second row? Okay.
Cindy Jamil, San Antonio Express News. Can we talk a little bit about what's next on the agenda for the mission? When do you turn on the instruments and test them, and how does that all unfold?
Well, the first things we do, starting about now, we will start exercising the propulsion system. We'll spin down the spacecraft to a nominal operating number of revolutions per minute. The spacecraft will continue to operate in a spinning mode. We'll exercise the other pieces of the guidance control system. In about 2 hours, we'll get the precise information about what our trajectory is. From what we observed during the acquisition of the signal, it looks like we're on a very nominal trajectory. The launch team did a great job of getting us on our way. We'll then start planning a trajectory correction maneuver that will take place in about 10 days. And there will be a second one in about 20 days. We'll then use that to clean up the very small amounts of change. We're going at something like 16 kilometers a second as we get off the vehicle. Pardon my metric system. We have about 300 meters, 0.3 kilometers per second of delta V ability to control the spacecraft. So they've done nearly all the work, and we're getting down to about the 4th digit of precision here, and we'll get all that cleaned up. We'll then do some initial checkout of the instruments. Next summer, we will go through a commissioning process of running through each of the instruments, being sure they're all operating. We can do in-flight calibrations using other objects in the sky. Then we'll start planning for the Jupiter encounter, which will start in the fall, and then get ready for that Jupiter encounter, which will take place late February.
Okay, thank you. All right, down here on the end. Wait for the micro. Yeah.
Next from the Daily Camera in Boulder, Colorado. As far as the Jupiter encounter goes, I know that depending on the launch date, which moons, what you'd have a chance to look at would change. I wondered if, knowing we've launched today, if you know yet, perhaps what we'll see at Jupiter.
We have a long list of objectives for the Jupiter encounter. And of course, there were a lot of combinations depending upon which day we might launch on. In fact, we have a science team meeting in about 2 weeks for our, what's called JESS, the Jupiter Encounters portion of our science team, to look at that. I don't have in my head, 2 days ago it would have been a different solution. I can't tell you that, Todd, but we can get that for you pretty quick.
All right, other questions? Okay, I'd like to open the opportunity for you gentlemen to, if you had anything that you'd like to say before we close out. Yes, sir.
I'd like to say one thing, and I think people here will find it interesting. First, I want to point out it's a very great honor to have Clyde Tombaugh's widow, Patsy, here again today, along with his daughter, Annette, and Wilbur Seitz, his son-in-law. And it's an equally great honor to tell you, on behalf of our science team, that some of Clyde's ashes are on their way to Pluto today. And it's really quite an honor.
All right, terrific. And with that, we'll close out this press conference. Thank you very much.
9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition and liftoff, and then New Horizons spacecraft.
Just lost it in the cloud. There it is.
9, 8, 7, 6, 5, 4, 3, 2, 1. We have ignition and liftoff of NASA's New Horizons spacecraft on a decade-long voyage to visit the planet Pluto and then beyond. Plus 15 seconds. Everything continues to look good as the Atlas V vehicle climbs away from Florida's east coast. We have ignition and liftoff of NASA's New Horizons spacecraft on a decade-long voyage to visit the planet Pluto and then beyond. Plus 15 seconds. Everything continues to look good as the Atlas V vehicle climbs away from Florida's east coast. The 5 solid rocket strap-on boosters are burning.
Wow, that's
6, 5, 4, 3, 2, 1. We have ignition and liftoff of NASA's New Horizons spacecraft on a decade-long voyage to visit the planet Pluto and then beyond. Plus 15 seconds. Everything continues to look good. 4, 3, 2, 1. We have ignition and liftoff of NASA's New Horizons spacecraft on a decade-long voyage to visit the planet Pluto and then beyond. Plus 15 seconds. Everything continues to look good as the Atlas V vehicle climbs away from Florida's east coast. The 5 solid rocket strap-on boosters are burning just fine, sending the New Horizons spacecraft on its way to the very edge of our solar system. T plus 35 seconds. T plus 40 seconds. One minute into flight.
Boosters throttle back, 75% thrust. SRB chamber pressures continue to look good. And SRB4 is burning out, and all chamber pressures are responding. And we have BOTA, RD-180s throttling up to 100% thrust.
T plus 1 minute, 45 seconds. Everything continues to look good.
Solids 1 and 2,
Boosters
3,
have
and
just jettisoned.
4, 5. Solid separation looks good.
Main stage still running fine. T plus 2 minutes and
Klappt. Die Raumsonde New Horizons ist auf dem Weg zum Planeten Pluto am Rande unseres Sonnensystems. Vor wenigen Minuten startete die Atlas V Trägerrakete vom Weltraumbahnhof Cape Canaveral in Florida. Die US-Raumfahrtbehörde NASA hatte den Start bereits zweimal wegen Windes und technischer Probleme absagen müssen. Die Sonde soll Pluto in 9 Jahren erreichen und Erkenntnisse über die Ursprünge unseres Sonnensystems bringen.
Das sind aktuelle Bilder vom Abend. Die US-Raumfahrtbehörde NASA hat ihre Raumsonde New Horizon ins All geschickt. Sie soll in 9 Jahren rund 6 Milliarden Kilometer zum Planeten Pluto fliegen. Die NASA erwartet neue Erkenntnisse über die Herausbildung unseres Sonnensystems. Der Start musste in den zurückliegenden Tagen mehrfach verschoben werden.
We have ignition and liftoff.
NASA's New Horizons spacecraft begins its decade-long voyage to planet Pluto and beyond.
3, 2, 1. We have ignition and liftoff of NASA's New Horizons spacecraft on a decade-long voyage to visit the planet Pluto and then beyond.
Cleared the probe for liftoff after 2 consecutive days of delays.
15 seconds.
Within 9 hours after launch, the probe will be traveling past the orbit of the moon, and you won't need to mark off your calendar for its return. The trip to Pluto will take nearly 10 years.
Hat die Raumsonde New Horizons am Abend erfolgreich auf den Weg zum Pluto gebracht, dem äußersten und einzigen unerforschten Planeten unseres Sonnensystems. Nach 2 wetterbedingten Absagen des Starts hob die Atlas-V-Rakete um 20 Uhr mitteleuropäischer Zeit vom Raumfahrtzentrum Cape Canaveral in Florida ab. Die Sonde ging damit auf eine fast 5 Milliarden Kilometer lange Reise, die fast ein Jahrzehnt dauern wird.
Die Behörde NASA hat ihre Raumsonde New Horizon ins All geschickt. Sie soll in 9 Jahren rund 6 Milliarden Kilometer zum Planeten Pluto fliegen. Die Wissenschaftler erhoffen sich neue Erkenntnisse über die Herausbildung unseres Sonnensystems. Die NASA hatte den Start in den zurückliegenden Tagen wegen schlechter Wetterbedingungen mehrfach verschieben müssen.
Die Raumsonde New Horizons ist vor 2 Stunden gestartet, der schnellste Flugkörper, den die NASA je in den Himmel geschossen hat. Schnell ist allerdings relativ, denn bis sie ihr Ziel erreicht, werden mindestens 9 Jahre vergehen. Im Jahre 2015 also soll New Horizons den Planeten Pluto erreichen und man darf gespannt sein, was sie dort zu sehen bekommt. Pluto ist der am weitesten entfernte und der geheimnisvollste Planet unseres Sonnensystems. Der Flug dorthin ist zugleich eine Reise in die Vergangenheit, denn auf Pluto ist die Zeit stehen geblieben. Besser gesagt, sie ist eingefroren. Hildegard Werth berichtet.
3, 2, 1. We have ignition and liftoff of NASA's New Horizons.
Es ist der Aufbruch zu einer Reise ohne Wiederkehr, wie bisher alle Missionen, die sich an den Rand des Sonnensystems wagten. Das Ziel ist Pluto, der 9. und kleinste Planet. Vor 75 Jahren ist er entdeckt worden und er ist so ganz anders als die anderen Planeten. Ein eisiger Winzling, der auf einer seltsam schiefen Bahn fliegt. 248 Jahre braucht er für einen einzigen Umlauf um die Sonne. Pluto hat 3 Monde, einer davon halb so groß wie er selbst. New Horizons ist die erste Expedition in diese dunkle, kalte Zone, wo die Sonne schwach wie eine alte Gaslaterne leuchtet. Wir werden viel darüber lernen, wie das Sonnensystem entstanden ist und wie es im Lauf der Zeit von außen bombardiert wurde. Das ist wie ein Geschenkpaket, wir wissen gar nicht, wo wir anfangen sollen. Seit Pluto entdeckt wurde, tobt ein Streit, ob er überhaupt ein richtiger Planet ist oder nur ein Asteroid. Er ist rund und hat eine Atmosphäre, aber andere Brocken dort draußen sind größer als er. Pluto war für uns immer ein Fremdkörper verglichen mit den anderen Planeten. Jetzt haben wir entdeckt, dass es dort draußen noch mehr solche tiefgefrorenen Brocken gibt. Da ist uns ein Licht aufgegangen. Jetzt denken wir, dass Pluto ganz gut hineinpasst zwischen diese Eiszwerge am Rand des Sonnensystems. Im Vorbeiflug hat die Sonde ein halbes Jahr Zeit, Fotos zu schießen und Messungen zu machen. Bis auf 10.000 Kilometer kommt sie an Pluto heran. Halt machen kann sie nicht, dazu ist sie viel zu schnell. Mit etwas Glück begegnet sie noch anderen Eiszwergen. Erst dann wird sich entscheiden, ob Pluto der kleinste Planet bleiben darf oder ob er degradiert wird zu einem Eiszwerg unter vielen anderen.